Hi there, Good Golf here with a tutorial on creating your own textures for Gaia and MegaSplat. I've been creating and collecting texture pictures for a few years now and decided to create a set to be used in Gaia with standard terrain and with MegaSplat to extend the texture libraries included in its examples folder. Okay, before I move into the Gaia standard terrain part of the tutorial, let's first look into some of the theory. So we start with making pictures with any digital camera you prefer. A big tip I read about early on is to avoid shadows where possible. Some of the tools which you can use to create texture maps can filter out the shadows. However, I like to stick to a consistent workflow and opted for the method to avoid the shadows. For this tutorial I've selected these 4 images, one for grass, one for gravel and 2 for cliffs. What do we need to have for Unity standard terrain? When you add a terrain texture, you will see the dialog asking for a albedo smoothness packed texture and a normal texture. The latter you can easily get, but the first one needs to be constructed. By far the easiest way to do so is by using Channel Packer. When creating a packed texture using the MATLAB 0.7 beta method, these are the settings you will need. For MegaSplat we will need to create 2 types of textures. First of all the standard texture, which basically is a diffuse map with the height map included in the alpha channel. The channel packer settings are the same as in the previous picture, except that we can use the red channel from the height map. Next are the NSAO textures. We will include 2 channels from the normal map, 1 channel from the smoothness map and 1 channel from the ambient occlusion map into a single texture. Again, these are the settings to use Channel Packer when you're using MATLAB 0.7. So I'm using MATLAB 0.7 beta, but this isn't the only available method. These are the 4 options I found in the past few weeks. MATLAB, but also Substance Bitmap-Material from the Algorithmic website. They also have Substance Designer, but I opted for the simpler Bitmap-Material. If you want to use free tools only, you can give it a try. The GIMP with Insane Bump. You will have to do the tiling manually, and I haven't found an option yet to create smoothness maps other than manually drawing them. For tiling there are quite a few videos on YouTube on how to do that. Awesome Bump. It's supposed to do the job too, but it doesn't run on my Windows 10 machine. And finally, here are some tips for the GIMP. Okay, so let's move to step 1, creating the texture maps using MATLAB. I have created a separate project to create the texture maps and included MATLAB and Channel Packer from the asset store into the project. I added the pictures to the project, so let's fire up MATLAB. Go to the settings and ensure the output size has been set to 1024. Pick one of the images to be used as the input. Go to the tiling option and synthesize. Send the result back to the main window. And finally, export the results. Note that the process is not extremely fast. For some reason the OpenCL option in MATLAB isn't working for me, so it's all done on the CPU. And these are the maps created by MATLAB. Albedo, ambient occlusion, emission, height, metal smoothness and normal. As an alternative workflow, here's how you would create the texture maps using Bitmap-Material. Open the standalone application, input the image, set the output size and maps, make sure smoothness or glossiness in B2M and ambient occlusion are selected. Enable tiling and set random tiling. Export the maps. Save as PNG to include alpha maps. The TGA format doesn't export these. This is important for the texture maps to be recognized as DXT5 format in Unity, and that's what you will need. Once you have created the maps, the next step is to pack the channels. I open up Channel Packer and run each of the textures through the process. Select the packing mode, select the output size, add a packed texture name and select the folder. Well, actually a name gets assigned if you drag in the first texture, so you can also wait and edit it after adding the textures. Drag the input textures to the slots and push the Generate button. For Gaia, select the packing mode as standard, add the albedo map to the albedo slot, add the smoothness to the height slot. We're sort of abusing the standard packing mode here to include smoothness channel into the alpha slot. Note that this is based on the MATLAB, placing the smoothness map into the .ms file's alpha channel. For MegaSplat NSAO maps, select the packing mode NSO, add normal and ambient occlusion to their slots, add the smoothness to the smoothness slot. Again, I have to set the input channel to alpha, since MATLAB is placing the smoothness map into the .ms alpha channel file. The next step is to apply the textures to Gaia standard Unity terrain. I already created a Gaia terrain, so let's give it a spin first. As you can see, it uses the default textures from gametextures.com. These are really great, but after a while you may want to use some other textures for a change. You can get nice textures from the asset store, but if you really want to have a unique look, then add your own. Well, that's sort of what I've been preparing for. So the easiest way to include our 4 new textures is by simply swapping the terrain splat textures in the terrain settings. This is a bit the quick and dirty method. If you want to do it the proper way, you should define these textures in a Gaia resource file and create the new spawning rules with the help of the visualizer. You can check my earlier tutorials for that, or check the video Adam recently uploaded to his Gaia collection of tutorials. So now we have added the 4 textures, so let's check how the scene now looks like. Next we will go and add the textures to MegaSplat. Step 1 is to add the diffuse height maps to the diffuse texture library. Lock the library, browse to the maps and add them to the array. Next, sort and update the library. Note that the maps you want to add need to be the same size and need to be in the DXT5 format after importing Unity. You cannot mix different formats into a single texture library for MegaSplat. Once we have added the maps, you will need to create the clusters. Typically, you would want to add multiple textures into a single cluster. Since I only made 2 maps for the sandstone texture, I can only mix these 2. The gravel and grass got their own cluster, which is just a shortcut for now. After having added the textures, I added MegaSplat to the terrain. I will not bore you with showing each step. Again, there are earlier tutorials in my set you can look at to check out how this is done. So this is the end result using the terrain with MegaSplat. Typically it would need a bit more of optimization. I think I overdid the tessellation a bit and the texture clusters could use a bit of variation. So adding more textures would be my first step to improve it. Let's give it a spin. I'm not sure whether increasing the texture map sizes to 2K or 4K would make a big difference, but it may be worth a shot. Remember that you can't mix sizes, so you would have to set up a complete new texture library for these sizes. When you look at Jason's examples, using the 1K maps in his example folders, I cannot but conclude that you can also do magic with 1K texture maps too. Also, some tweaking of the texture map settings in MapLab may be useful. Some of the normal and height maps for the generated textures do not have a lot of definition. There are some dials to change in MapLab and optimize these to your liking. Okay, that concludes this tutorial for now, and I hope you liked it. If so, then please upvote this video. Oh, and before I forget, I will attach the texture maps I used in this video in a zip file for you to use in your own projects. Please check the Creative Commons license included.